Alright, now we're on to the first IA review practice exam for physics. This here, I'm working on the honors version of the document. The Regents regular version only has one less question, and that's towards the end. If you're here just to check your answers after doing the practice exam, you could just skip towards the end. I'll have the answers all laid out. But if you want a step-by-step for each question, then just stick along. And we're going to start here with number 1. Alright, so here, car travels 90 meters due north. Oh, nice, highlighting. In 15 seconds. Car turns around and travels 40 meters due south in 5 seconds. So we're looking for average velocity. So in this case, we're traveling not in a straight line, so we're changing directions in our path. Oops. Yeah, that's not pretty. Let's do it this, sorry. So changing directions means that distance and displacement are not the same thing. So that means speed and velocity are not either. Okay? So because we're looking for velocity, then we're going to look at displacement over time. So our displacement here, we're going 90 north and then 40 south. Going up and then down. So overall, this leads into 50 meters going north. That's our displacement. And then our time is 20 seconds. So V equals 50 meters over 20 seconds. You get 2.5 meters per second as your answer. Alright, number 2. How long will it take an object to move 100 meters if the object's traveling with an average speed of 0.5 meters per second? So our speed here is 0.5 meters per second. Move 100 meters, so meters is a unit for distance. So we're looking for how long will it take? That's time. So V equals D over T. 0.5 meters per second equals 100 meters over T. Cross multiply this way and this way, you get 0.5 T equals 100. So that means T is equals to 200 seconds. Choice A. Number 3, a car moving at a speed of 8 meters per second enters a highway and accelerates at 3 meters per second square. How fast will the car be moving after it is accelerated for 56 meters? Alright, moving at a speed and then accelerates. So that means we have initial of 8 meters per second. We're looking for how fast will it be after. So final velocity is unknown. They gave us acceleration as 3.0 meters per second squared. Read the problem carefully. The unit is also meters per second squared. Distance is 56 meters. Meters is the unit for distance. We're looking for final velocity. So given these pieces of information, you need to use this kinematic equation. So VF squared, we're looking, and then 8 meters per second squared plus 3.0 meters per second squared times 56 meters. Plug and chug. Make sure you take the square root at the end, and you should get 20 meters per second. That's choice B. Alright, number 4. A boat initially traveling at 10 meters per second accelerates uniformly at the rate of 5 meters per second squared for 10 seconds. How far does it travel? How far? Distance is unknown. Initially traveling at 10 meters per second. Meters per second is a unit for velocity. And it's initially 10 meters per second. Accelerates at the rate of 5 meters per second squared for 10 seconds. So that means we got to use this guy. One of my favorites. Plug and chug. Solve and you get 350 meters. Alright, I want you guys to skip number 5 because this is a kind of question, given the kind of scenario you don't really need to worry about. I would skip number 5, but if you're curious to know it anyway, number 5. So we're looking for average speed. This is a shortcut method to find average speed if you're accelerating. So your VI is 0 meters per second, VF is 50 meters per second. So average speed, you just add the two together, divided by 2. So 50 plus 0 divided by 2 should get you 25 meters per second, which is our answer for choice C. But I'm calling it optional. You guys don't need to worry about that one. Now, number 6. Oil drips at 0.4 second intervals from a car that has an oil leak. Which pattern best represents the spacing as the car accelerates? So for acceleration, you want to start off slow and then go fast. So that means the dots are close together, whereas they're going to go fast, it's spaced apart. So you want to start off something like this. The best one is choice B. Number 7. During which interval is the cart moving forward at constant speed? So we need to look that we have a displacement versus time. On our y-axis, we have displacement. So we're talking about your position away from start, from 0. And we're looking for moving forward at constant speed. Constant speed, we're moving at a constant rate, changing your position at a constant rate. So the ones that show that are BC and DE. BC is going up and DE is going down. So moving forward, that means we're going in the positive direction. So that means we're looking at BC as our answer. That means you're changing your position at a constant rate. Each second you go forward. Whereas here, C and D, you're staying at the same position as each second passes, so you're not moving at all. DE shows you're going backwards in the other direction. You're going backwards at a constant rate. So yes, this is also constant speed, but you're going backwards. A and B shows an exponential increase in your distance. When you're moving forward at an exponential rate, that's acceleration. So AB is acceleration, BC is positive constant velocity, CD is at rest, and DE is negative constant velocity. All right, now number 8 is a doozy whopper. Excuse the language. Not that it's a bad word. But anyway, number 8. What is the total distance traveled by the object during the first 4 seconds? Here we have a speed versus time graph. That means when you look at it, how can you find distance? You have speed on the y, time on the x. What can you do to find distance? So if you remember this, very few might, because we only probably went over one example and a few. So when this happens, on a v versus t graph, distance or displacement can be found by area under the curve. So that means we need to find the area of this shaded region underneath the graph from 0 to 4. So it looks like a triangle. So we need to find the area of that triangle, 1/2 base times height. And we go by the intervals, not the boxes. So from 0 to 4, that's our base. That's 4 seconds. And our height goes from 0 to 20 meters per second. That's 20 meters per second. Multiply all that together and you get 40 meters. So the car has traveled 40 meters within 4 seconds. Okay? Now what happens if you have different intervals? Like let's say if you go from 1 to 3, something like this. Then you're probably going to need to break it up into shapes that you know. Like right here, you have a rectangle, and up here, you have a triangle. So break it up into shapes you know if you have a weird interval like that. All right, 9 and 10 are going to be devote a whole chunk of space here. All right, so number 9, this time we're looking for the acceleration. of the car, we still have a speed versus time graph. If you think back, acceleration is a change in velocity over time or change in speed over time, depending on the context of the situation. So this is the same as if you had change in y over change in x. What does that look like? Slope. So you're finding the slope of this graph. You can pick 2 points on this graph, pick easy ones. So you go from 10 meters per second minus 0 meters per second over 1 second minus 0 seconds. You get 10 meters per second squared. Choice C. Now number 10. You have a speed versus time graph. So we're talking about the car's speed over time. Here, speed of car B at 6 seconds. So 6 seconds is over here. Car B is up here. That's 10. And car A is over here at 8 meters per second. So car A is less than car B. Choice A. All right, number 11. You have a painter going up the ladder, 7.3 meters, and then going to the right, 11.0 meters. We're looking for the displacement right here from point A to point C. So it looks like a right triangle. You're going to do Pythagorean theorem here. 7.3 squared plus 11.0 meters squared equals C squared. Pythagorean theorem, you get C is equal to 13.2 meters. Choice B. All right, now number 12. Let me do a different color. By the way, if you guys didn't know, my 3 favorite colors are purple, green, and blue. So if you want to get me something, or if you start to notice why I have picked these 3 colors, it's because they're my favorite. Anyway, moving on to purple. 12. A mass is moved 9 meters north and 12 meters east. The magnitude of displacement is, all right, 9 north, 12 east, displacement. If you guys happen to realize, this is a 3, 4, 5 triangle. Or the other way around. So this means the question mark we're looking for is 15 meters, but you could also do Pythagorean theorem to figure it out. (13) is kind of tricky, I would say. A displacement vector, this time we're looking at the hypotenuse. It's 20 meters. Could have perpendicular components. That means we're looking for these guys. What are those? Hint, hint, it's almost like a 3, 4, 5 triangle. So if you take 20 divided by 5, or you could guess and check with each of these choices. Know that when you add up the 2 legs, they should be greater than the hypotenuse. If they're equal to or less than the hypotenuse, then you're doing it wrong. So you can already knock out choice A, 10 and 10. You can also knock out B, 12 and 8. So between C and D, you probably have to guess and check, use Pythagorean theorem, and you should get choice C. But a more relevant example of what you'll see on the IA will be the perpendicular components of AY and AX, where you have to solve for these guys. Most of you did pretty well on the fundamentals quiz in that question, so I'm not too worried about going over that. You guys are capable of doing that. Just remember, theta is angle, A is the vector, and you solve for AX and AY. All right, number 14. A hiker travels 1 kilometer south, turns and travels 3 kilometers west, and then turns and travels 3 kilometers north. What is the total distance? So total distance is the same as total path taken, not the shortcut. So you go 1 south, you go 3 west, and then 3 north. So 1 plus 3 gets you 7 kilometers. Number 15, scalar is to vector as speed is to velocity. So that you kind of have to know for 15. So remember, scalars are magnitude only and vectors are magnitude and direction. So examples of scalars that we already talked about are distance and speed. Whereas as vectors, we talked about are displacement, velocity, and acceleration. Keep in mind, speed and scalar S's, vectors and velocity V's, S and V. That's a good way to remember that specific example. All right, number 16, the speedometer in a car does not measure the car's velocity because velocity is a vector. Definitely a vector, and it has magnitude and direction. So think vectors like arrows. So that's choice A. 17, which is a vector quantity. Speed is not, mass isn't, work isn't, it's displacement. Let's do 18. A car is moving with a constant speed of 20 meters per second. What total distance does the car travel in 2 minutes? So 2 minutes is equal to 120 seconds. You just multiply by 60 seconds in a minute. So V equals D over T. 20 meters per second equals D over 120 seconds. 120 times 20. D is equal to 2,400 meters. Choice D. Number 19 is a 2-step problem, so you need to do 2 different equations. Hey, look, it's red, white, and blue. All right. So we got her speed was 2 meters per second at point A, and then when she gets to point B, she speeds up to 3 meters per second. Initial velocity is 2 meters per second. Final velocity is 3 meters per second, and she traveled a distance of 5 meters. We don't know acceleration, but we need to find time. All of the 3 kinematic equations need acceleration. So the first step is to find acceleration. And we got to use this equation. And so that's 3 squared equals 2 squared plus 2a times 5. So 9 minus 4 divided by 10. You get 0.5 meters per second squared as your acceleration, which you then carry over to solve for time. So then you can use this equation, the prettier one, because this is short and quick. 3 equals 2 plus 0.5 times t. T is equal to 2 seconds. There's only one 2-step problem on the IA. Number 20 is for the honors class, so they have to do free fall. So number 20, a baseball is dropped, keyword there dropped, so initial velocity is 0 meters per second, and it's falling vertically, so your acceleration is that number, 9.81 meters per second squared. Acceleration due to gravity is a constant value. So you're accelerating at a constant rate, but when you're accelerating, you're speeding up. So you're increasing speed. We also have 3.1 seconds, and we're looking for the height of the building, which is distance. We're going to use this guy. So initial velocity is 0, so that cancels that out. Plus 1/2, 9.81 times 3.1 squared So do the math, plug and chug. This guy cancels out to 0, so D is equal to 1/2 9.81, 3.1 squared, and you should get 47 meters approximately. Choice C. Alright, and that's the end of this video. On the next slide, I'm going to sum up all the answers in a single neat format. You should probably keep an eye out for the content review on 1D kinematics. That's coming up later. And hopefully you should also check out the motion graphs video on everything on motion graphs. The 1D kinematics talks about the basics of motion and kinematic equations and a little bit of free fall. So stay tuned for that. Otherwise, move on to the next couple of seconds and there should be the answer key. Bye!